Okay, uh, so the Dutch national flag problem. Uh, so the very first approach that comes to my mind would be to count the number of zeros, ones, and twos, and then accordingly, uh, you know, sort them. Int n would be nums dot size, and then int zeros, ones, twos, and then you iterate twice. No, you can. Yeah, you don't need to iterate twice. I plus if nums of I equals 0, then zeros plus. I don't know if you can hear me because I'm not wearing the earphones and it's pretty loud outside. Okay, 0, 1, 2. This will be ones, this will be twos, and then our entire equals zeros. Uh, I plus i's and then I plus. So first, wait. Thinking of a really dumb way to do it, but I think there's a better way. Zeros, ones, twos. Hmm. How do I do it with brute force? How did I do it with brute force? That's not brute force, but override the array with total number of zeros. Yeah, that's the only way you can do it, I think. If you're trying to do it with brute force. It'll be I is less than zeros. I plus. Then nums of I equals 0. And then you go for int I equals zeros. I is less than zeros plus ones. I plus. Nums of I would be equals to 1. And then you go for int I equals ones. I is less than zeros plus ones plus twos. I plus. Nums of I would be equals to. And then I think it's a void. Yeah, it's void. So if you try to run it, I think there will be some problem with the yeah. Oh, do I need to initialize them? Hmm. What could be the problem? Okay. How do I initialize multiple? Okay, I need to do that. equals 0 equals 0. Okay. Wow. Okay. It's the same thing that I've written. If this works, what's wrong with mine? What's wrong with... Oh, okay, wait. And zeros, ones, twos. And zeros, ones and twos. Is there some zeros, ones, twos, zeros, 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 ones, zeros, ones, twos? What's fucking wrong with this? What's wrong with this? Shouldn't I third loop? Starts from ones instead of zero. Okay, 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 okay. And this should work. Now, uh, now how do I do it without this shit? I can think of the closest thing that comes to my mind is 2 or 3 pointers. So, let's say, let's try to do it with 2 pointers. If I try to do it with 2 pointers, first, where am I gonna place the pointers? The first pointer would be obviously at the beginning, and the second pointer would be iterating through the array. As soon as the array it's the second pointer hits 0, it's gonna... What about... Okay. I think it needs 3 pointers. So, one for 0, one for 1, and another one for iterating through the array. Okay, I think I have a plan in my mind. So let's say int start equals 0, mid equals 0, or let's say int zeros, ones and twos again. Ones equals 0, and then twos equals 0. And then I'll take the array, I'll iterate through the whole array. I less than nums dot size I plus plus, and then let's say, okay, so we are gonna iterate the twos pointer, alright, and I think we should use while instead of for. While zeros is less than ones and ones is less than twos, or maybe let's try to do it with here. I hit 0, I swap it with 2. I hit 1, I swap it with the next. Okay, the next. Okay, this is kind of complicated. I, J, K, yeah, they use 3 pointers as well, and then while J is less than K, nums of J is equals to 0, swap nums of I and nums of j, and then increase both of them. It's 1 increase only j. Oh, he placed num k at the end. Wait. Not this. Go check out. Keeping count of value. This is what sort. Yeah. And then optimal would be 3 pointers, low, mid, and high. Uh, Array of low to 0. Yeah, this contains 0, this contains 1, and this contains 2. Alright. The middle part is an unsorted element, so hypothetically the array will be different markers will look like following. 0 to low minus 1 extreme less will be zeros, and then this to this index low to mid minus 1 would be the ones containing unsorted, and then this. Okay. In our case, we can assume that the entire given array is unsorted, so we can place the pointers accordingly. For example, the given array is 2 0 1 1 1 0. The array with 3 pointers will look like following: low, mid, and then high. Alright. Here, as the entire array is unsorted, we have placed the mid pointer at the first index and the high pointer at the last index. The low is also pointing to the first index, as we have no other index before 0. Here we are mostly interested in placing the mid pointer and the high pointer as they represent the unsorted part of the hypothetical array. Alright. Now let's understand how the pointers will work. We will first run a loop that will continue until mid is less than high. So this portion represents the unsorted array, mid and high, the one between mid and high. The one after high should be sorted and before low should be sorted. Okay. There can be 3 different values to the mid pointer, that is 0 1 2. We will swap low and mid and increment both low and mid. Now subarray from 0 to okay. Just increment the mid pointer and then because we don't want the mid. Okay, we swap the mid. This makes sense. So this would be while once is, would it be less than or equal to, or would it be? I think it should be less than or equal to. Yeah. So first, if array of ones, this should be initialized to nums dot size -1. If arrays of ones equals 0, then swap array of ones comma array of zeros, and then increase ones and increase zeros. If it's ones equals 1, then you just gotta increase ones, and then if array of ones equals 2, then you gotta decrement. You gotta swap first. Swap array of ones and array of twos, and then you decrement twos. Yeah, that's pretty much it. Fuck's sakes, it's nums. What's wrong with this? What's wrong? Oh. Heartbreaks is one thing, but egos are another. Beg you don't embarrass me, motherfucker. Do you have to increase once? No. Array of low, array of mid, that's what I'm fucking doing. So 0, 0, 1, okay. 2 is not getting sorted. There's an edge case fuckery going on. Edge case fuckery going on. Yup. What do you think? I don't see anything wrong. Wrong. Swap 0 or 2. The value at one's index might not have been checked, so you need to help. 6 less than 2 if nums of 0 is swap, and then if nums of 1 ones. Do not increment here since the swap element needs to be checked. What's I am not incrementing shit there. Bro, I'm not incrementing shit. And if this one works, I'm gonna fucking kill myself. Guess what? It works. I fucking knew. But what's so different? Oh, it's an... Okay, it doesn't matter if it's an else if or an if. I'm not incrementing ones there at all. What the fuck? He fixes when you swap a 0 to 0. Correctly increment both zeros and ones. Yeah, I'm doing that. Also if you increase ones, yeah, I'm doing that too. I have not incremented one, as you can see in the code. What's wrong? Yeah, but still, the problem lies in the sequence of the if statements. Specifically, when the number is 0, the algorithm correctly swaps and increments ones and zeros. However, if number of ones is 1, it increments 1, which is fine. The problem occurs when number of ones is 2 and you swap nums of 1 with nums of 2. After this swap, the new value at nums of 1 is not checked immediately, which could cause an error. If the swap value is 0, oh, you have to write an else. Shoot, this one. You don't need a fucking condition in an else, you know that, you fucking dumbass. You dumbass. So, you dumbass. Yeah, what's wrong with it? I still don't fucking get this, to be really honest. Dutch national flag, alcoholics. Oh.
Hello everyone, how is it going? My name is Ubaida. I'm a software engineer at Facebook, and welcome to my channel Code Smart. Today we'll discuss about Dutch national flag problem. Dutch national flag, aka DNF, is a very well-known algorithmic problem for coding interviews, especially for FANG companies. It was first proposed by Edgar Dijkstra. We all know Edgar Dijkstra, one of the brightest minds in the history of computer science, who happens to be a Dutch by nationality. By the way, he's also one of my favorite computer scientists ever. The flag of the Netherlands consists of 3 colors, white, red, and blue. Our objective is to group the colors together and maintain the correct order. So if you look at this solved problem, we grouped blue together, we grouped white together, and then we grouped red together. Or it could be red, white, and blue. In other words, this is a sorting problem.
Is he alive? Oh, he's dead. Dropped it down. What's he doing? Don't tell me he's not a fucking... Bro, come on, bro. Use your fucking computer science genetics. What the fuck you doing with bones and shit? God. Wasted fucking potential. Oh no. Oh, what? Air France. He works at fucking KLM. Is he a pilot? He's a... Yes, no. He's a computer engineer. Let's go. Musicology. What? Yeah. Thank God it didn't. Technical project analyst, site reliability engineer. Damn, that's one long list. Marcos. Oh, all of them are on LinkedIn, Linked and God. Senior software engineer, architect, solid experience. Oh, okay. That's good, bro. That's good. What about this one? Even she's an engineer. Oh, it's... yeah, it is. No, she is not an engineer. Sad, bro. He got the fucking... oh, he got an award named after himself. Pew. Dijkstra Prize and... Damn, bro. Turing Award. Bro, I wanna get a fucking Turing Award. I don't think I can get one. But
of 3 unique values. For example, imagine we have an array consisting only 0 and 1 and 2, and then we need to sort that array. In that case, that would be also a DNF problem. The main idea of this algorithm, proposed by Dijkstra, is to push all the low values to the left, high values to the right, and we don't care about the mid values, because if you push low values to the left and high values to the right, all the other values, low values to the left, high values to the right, and we don't care about the mid values, because if you push low values to the left and high values to the right, all the other values will fit into the middle eventually. This is a sorting problem, so it could be solved in different ways. Probably the most obvious way is to just sort it using any well-known sorting algorithm. It could be merge sort or the quick sort. In that case, the time complexity would be order of n log n. Another way of solving this problem would be do some sort of counting sorting. So we count the number of whites, the number of blues, and the number of reds, and then we combine all together. It would be order of n time complexity, but we need to go through the arrays more than one time, so multiple passes is required. The solution proposed by Edgar Dijkstra, it is order of n time complexity and constant space complexity. So this is the best known solutions for this problem, and we're going to discuss the solutions proposed by Edgar Dijkstra. So in this solution, we'll maintain 3 pointers. So if you look at these arrays, this is partially sorted. What we're doing here is we're going through these values one by one. We know all these values and these values and these values with black color and the question mark in the middle, those are unknown. And we'll maintain 3 pointers, low, mid, and high. And using those three pointers, we will keep 4 invariants. So the number 1 invariant is everything at the left of low is low values. So what does it mean? So this is the low pointer. So everything at the left would be low. So here the low values is blue, and then from the low pointer to the left of the mid pointer are mid values. So this is low pointer, including this low pointer until the left of this mid pointer are mid values. And then from mid pointer to the high pointer, including mid pointer, including high pointer, all those values are unknown. We don't know about those values yet, but we're going to reveal those values in our algorithm. And then everything after the high pointer are high values. In this case, this is red color. In another way, we can say that the low pointer is always the first mid value or the first value after the low values. Why do we do that? Because whenever we find a value, which is a low value, then we need to swap it with the low pointer. So where can we swap it? This is the place where we can swap a low value. And then the mid value, we can say the mid value is the first unknown value. So we'll always reveal this value and try to find out the correct positions for this value. So in another word, this is the first unknown value. And again, the high value, we said everything at the right of this high value is high value. So high pointer will point to the last unknown value. So if you can understand that or remember that, it will help us to write the correct code for this algorithm problem. So today I have some plain cards with 3 different colors, and I will use those cards to explain this algorithm. Let's get to that solution. I'm going to use these plain cards to explain the DNF algorithm. I have colored the other side of this card in 3 different colors according to the Dutch national flag. I have some red cards, I have some blue cards, and I have some white cards, and we're going to sort it using DNF algorithm. I'm going to shuffle it so I don't think it will be completely random, and I'm going to put it here. Okay, and then I have 3 pointers. One is the red one, which I will use as a high pointer.
So fucking cool.
One is the white pointer, white. It's not actually white, but I will use it as a mid pointer anyway. And this is the blue one. I will use it as a low pointer. So the first thing first, the initializations. Initially, the mid pointer and the low pointer will go to the first card, which means if it is an array of length n, it would be the 0th index, and the high value, the red one, will go to the last one, which means it will go to the n-1th index. So if you remember, our objective is to traverse the array, reveal each and every card one by one, and find out where can we put that card. And the main idea behind this algorithm is we'll push the low values to the left, we'll push the high values to the right, and we don't care about the mid values because it will be eventually in the middle. So let's get started. So this is our first card. We'll reveal it. We got a red card, which means this is a high value, and our objective is to push the high values to the right. So to which positions we can push it, that's why we have this high pointer. What we are going to do is we're going to swap it with this high pointer. So it will come here, and this one, we don't know the value of this one yet. It will come here. So just
Then
be
unknown,
a
so you gotta check that before you know. So once you swap let's say this is 2. Once you swap 2 with the mid pointer, this thing would be still unknown. So you gotta check that again before you move forward. So you can't do. Okay, wait.
swap, and since the high pointer, everything on the right of the high pointer should be the high values, so this high pointer will move forward. It will come here. Our mid pointer is still here, so
How the fuck does that do when n passes? And it should probably take more than n passes. Right? It should. No, it's okay. Wait, while high is less, it's while mid is less than or equal to high.
as I said earlier, the mid pointer will always point to the first unknown value. So these are all unknown. This is the only known values here.
Does this algo take n passes or more than n passes? N being the size of the array. Exactly one pass over theory, making it an single pass logic. N, let's say n iterations. Since I'm not passes, exactly n iterations. So how does it? You can't see me now.